Exercise A01 is going to get us started linking what we learned during this module on the data structure, user-defined data structure and types in our programming language. And it's going to allow us to link it to actually what we already covered, which is using parameters with function, allocating dynamically memory, manipulating arrays, etc. So we are going to start in this first exercise um, by you defining a data structure. Okay, we are going to call it struct record underscore s. This data structure will correspond to a very minimalist employee record. Each employee record will be containing a long named SSN and an array of fixed size equal 20, an array of char, which is going to be the name of that employee, and that's it. So that's going to be one record. We are going to define this data structure in a01.h. Then we are going to have a a01.c file, which is going to allow us to implement all the functions that we're going to talk about in a second, and which are meant to operate on the struct record as data structure. And then we'll have finally a little main.c, which is going to allow us to do some interactive testing of those functions. So the first part, as usual, is to break down the code into different files. Okay, so this is how the a01.h file will look like. Our usual precompiler directive trick here to avoid multiple inclusions. Then we define our structure record s. Struct record s, semicolon at the end, don't forget that. And in the middle, here, definition of our fields. So we have a long social security number, and we have a char name, an array of 20 character here. Let's save. That defines our data structure. Now we have the header here of the three functions we need to write. So I'm going back here to the exercise definition. The main.c real quick is just going to display, it's going to just be there to prompt the user to call those functions. Okay, so we're going to come back onto that in 1 second, but really this is going to be the easy job in this exercise. What is going to take us a little bit more time once we define the data structure, which I already showed you, is going to implement the scan data function, which returns nothing, takes an array of those struct record s, and takes a size, which is a number of elements in that array. And it's going to ask the user for information to fill all of those employee records. Display data at is going to take an array of those employee records as first parameter, and an index, second parameter. We'll assume that whoever calls that function is going to provide an index that is valid, that is non-negative, and certainly not exceeding the size of this array. So if we were to play a little more seriously on that first exercise, we would probably ask instead for the caller to provide us the array, the size of the array, and the index, and we would do ourselves in this function all the tests relating to whether we are out of boundary or not with that index. But right now we're going to do a simplified version. Display data, well, takes an array, its size, an array of records and its size, and display one element at index, display all the elements in that array. Once you implement already display data at, you realize that you can easily implement display data by just calling repetitively display data at for each index inside of this array. This is exactly what we are going to do. So we have a better view now of what we need to implement. Let's go back to the code. A01.h, we have simply the signatures, the prototypes of those functions here. We have the definition of the data structure. We're pretty much good with that file, so I'm going to minimize it. Let's go to main.c. Well, main.c, I tried to make it like straightforward as well. We have here an array called myData of element of type struct record s. We need n of them. N is defined here as equal to 5. Okay, so this is just what we are going to test our function on, an array of 5 employee record. Then we have here a printf. Let's read, n employee record. Call scan data with myData n. Then let's display n employee record, call myData with the size n. And then which employee would you like to display? Read an integer value which we call index and declare here, and call display data at on this array for this particular index. So this is going to be our little test environment. Okay, you see that it's interactive because we are going to keep typing data information for the employee, display it, verify by hand that it's the same, and then display an employee at index, sorry, and verify by hand again that it's the same. The last part we have is a01.c, which includes, of course, a01.h, and the three functions we need to implement. So let's get started by scan data. We're going to proceed in less than the usual code a little, test a lot, code a little, test a lot method. We are going to proceed here and we're going to implement those three functions before we start testing. Reason is that they're kind of interrelated, okay? You need to be able to read data to be able to display something meaningful on the screen, and to display all the content of the data array on the screen, you need to be able to display one element. So really here, this is three small functions which need one another pretty much to lead to meaningful testing. There are ways where we could break it down into little chunks, into little segments, but I would take more work on the testing main.c file. So we are going to go for a simple solution here. Scan data, read data from the user, pad it up into that data parameter, which is an array of struct record s element. So this one is going to be relatively simple. We know that we are going to have to iterate over all the elements of that array, so that calls for a counter-controlled loop. So let's define our index. I equal 0, I lesser than size, okay, classical iteration over all the elements of a given array. I'm putting here my loop. For each element of this array, I need to ask the user, enter, well, let's do it differently, employee number %d. So that's going to be a little message that's going to tell us which employee record we are filling. And so we are going to display here the value for I. Employee number %d. Let's go to the next line. And we are going to display another printf. I'm using tabulation here to space out a little my work. And I'm going to ask name equal from the user to give me a name. And I'm going to use a scanf here. I'm putting dots here because I'm going to come back and fill it in 1 second. Printf to tabulation ssn equal, and I'm going to scanf social security number. And when I'm done with all of this, when I'm done with employee I, I'm done with my loop. So you see that I left a couple of blanks here. Why? Well, I need to think about what I'm doing here, since this is the first time we're going to access a structure variable inside an array, and more specifically access each of the fields of a structure variable, which is itself an element of an array. So let's start by thinking about what we need to read. %s, I need to read one word. This is what %s means, by the way. If you didn't complete the tokenizer exercise from last module, the review module, you probably missed that the way to read an entire line made of several words in C is actually to use different function like fget_s, or like we use in the tokenizer getLine, which is even more convenient, shall we say, to use. If you use scanf%s, you are reading only a single word. Really important. So here I'm reading a single word, and I want to store it in the field name of the data structure, which is element index I in the array data. So I'm accessing array data index I. This is a structure element. I'm accessing the field name of it by using the dot name notation. The data type of this field, data index I dot name, is an array of character. So I don't need ampersand here. Okay. So I'm reading %s data index I dot name. Data index I dot name has a maximum size. I do not allow more than 20 characters in that array. So if I wanted to here develop a little bit more secure code, I would limit scanf to read only a word. That's what %s does, and only a word which is 19 character maximum, leaving 1 character for the terminating \0. Okay? Alright, then I need to read a social security number here. So %LD, and I need to access data index I.ssn. But this time this is a long. This is not a pointer, so I need to put ampersand in front here to provide the address. Well, let's save. And even though we cannot test thoroughly, we are going to compile to make sure that we don't have syntactical error, and we're going to get it to run, so that if we messed up something with our scanf, if we didn't access properly, the fields, etc., we are going to get a segmentation fault. Okay, we are going to have our program crashing due to misuse of pointers. So that's going to be already something to detect. a01.c is compiled with main.c. Syntactically, it's correct. A.out. Reading data for 5 employees. Employee number 0. Name equal Joe. Social security 123. Employee 1. Name equal Smith 456. And we keep going like that. This is employee 3. 789. 4. 123 again. Employee 5. 456. Displaying data for the 5 employee. Well, nothing happened. We didn't write any code in the function, that's why. Do you want to display a specific employee? Sure, employee number index 3. And there you go. No code in that function ever. So at least we didn't misuse a pointer in a way that would cause our program to crash immediately. So that's as much as we can test so far. Now when we do display data at, we're going to be able to display one employee record at index I. As I said previously, if we had to rewrite this not as a learning exercise but as a real application, we would have to spend some more time, trying to figure out here how we can check this index as being a valid index in this array. So right now, this code is not really solid. We're just going to go for a simple approach, assume that when we are called, the index I has the right, correct, valid value. So let's work with it. What do we need to display? Printf, employee number, %d, name equal %s, ssn equal %ld. Next line. And now we can provide here the number of the employees I. The name of the employee is data index I dot name. Okay, now the scheme to access fields inside a structure, inside an array should become clear. Data index I dot ssn will be the social security number. And what happens if I need to display all the employees? Well, counter control loop for I equal 0, I lesser than, we called it size, I plus plus. What do I do for each of those employees? I call display data at, I pass my array, I pass my index. And I'm done. Let's try this. Save. Go back to Conqueror. Compile. Syntactically this looks okay. Execute. Okay. Instead of typing any type of name, I'm going to type names and number that are going to allow me, when I see the employee being displaced, to make sure easily that this is the correct information. If I use random character data type like E, J, K, I, O, P, etc., when I see the result, I'm not going to even be able to tell easily, if there is a problem or not. So instead, I'm going to use names such as 1, SSN 1, 2, whoops, 2, SSN 2, 3, you get the scheme now, 4, 5. So when the program displays the names, the social security number, etc., it's really easy for me to make sure this is the one that I entered. Now if I ask for employee at index, let's go for 3. Employee at index 3, name is 4, SSN is 4. So we have functional code there. I'm going to show again the code, very small code, and we're done with this exercise.